welcome. This is Augustine Emeka from Tclassified.com. Today I'm going to be looking at the concept of artificial intelligence. Artificial intelligence is one of the major aspects in computing that has been gaining much news, and people have been learning so much about it. So today we're going to be looking at it in details. Please, if you like this channel, for you to get more information on artificial intelligence, on how to go about coding it, hit the subscribe button. So we're going to be starting immediately. Now, what is artificial intelligence? Artificial intelligence is an area of computer science that emphasizes the creation of intelligent machines that work and react like humans. So basically, what you learn in artificial intelligence is how to make machines to behave like human beings. Some of the activities computers with artificial intelligence are designed for include speech recognition, learning, planning, problem solving. So when you say that a machine can do artificial intelligence, that means that machine can actually learn. If you bring a picture of a goat, the machine should be able to tell you that this is a goat. Just like human being can look at a goat and say this is a goat. Look at a monkey. A human being is able to classify different animals into monkeys and goats. The same way, a machine should be able to do that. Once a machine can do that, then you can say that that machine is artificially intelligent. It can also do speech recognition. It can recognize, just like a human being, when I hear the voice of my father, I can differentiate it from that of my mother. A machine can be able to do that. Learning, a machine can learn and be able to classify, just like I said before, goats from sheep. Machine can also plan and do other problem solving. So once a machine can do all this, you can say that that machine has the AI ability, has the ability of artificial intelligence. Now, in the field of artificial intelligence, you normally hear about AI, you hear about machine learning, deep learning. These words sometimes they are interchangeably used. So how do you know how to classify them? Now, anything about machine learning and deep learning, they are all classified under artificial intelligence. It depends on the approach. So artificial intelligence is when you mimic the intelligence of human beings for machine. Whereas machine learning is a technique by which a computer can learn from data without using a complex set of different rules, that is, without being explicitly programmed. This approach is mainly based on training a model from data sets. So when you train a model or when you train a machine, when you continue supplying the machine the pictures of a goat and that of a cat, and you continue telling the machine that this is always a cat, this is always a goat, the machine will have the knowledge to be able to classify on its own. So machine actually learns from data. That's what we call machine learning. Now, deep learning is a technique to perform machine learning inspired by our brains, our network of neurons. So whenever you're talking about deep learning, it's also a method of teaching machines something, but this time around you're modeling the algorithm based on the brain of a human being. So you can see that both machine learning and deep learning are approaches to solving problems of AI. They are approaches to making machine to be intelligent. So you can either use machine learning, in which way you're doing explicit algorithm that enables machine to learn from data, or you do deep learning when you are modeling your algorithm according to the neurons of the head of human beings. Now let's look at machine learning, then afterwards we look at deep learning. What is machine learning? Machine learning is an application of artificial intelligence that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. Machine learning focuses on the development of computer programs that can access data and use it to learn for themselves. So in machine learning, actually what the computer does is to pick data. You keep feeding information or pictures of car, truck, bicycle and everything. The computer all of a sudden starts recognizing that whenever I see something like this is a car. Whenever I see something like that, this is a truck. Whenever I see something like this is a bicycle. So whenever it now sees a single picture of a car, it can be able to categorize and tell you that this is 95% of a car, and therefore it is a car. So that's actually what machine learning does. To learn from data, you must have supplied plenty pictures of cars and other things, so that the machine will now be able to classify and tell you that this is this. That is what machine learning is. Now, machine learning problem could be of various types. It could be a problem of classification. You want the machine to be able to, anytime you receive receives email to be able to tell you that this email is spam or this one is original email. That is classification. You're classifying because you are telling it that anytime you see such thing in a email, that email is a spam, just like you have in your mail, Gmail or Yahoo. So that is a classification problem. You're classifying between two things, spam or not spam. Regression is when you're you're telling the machine to learn from features or from other characteristics to be able to predict what will be a value, a discrete value. That's what we call regression. Like you want to predict the price of stock from what is happening in the stock market. That is regression. Clustering is when you also classify, but this time around you don't know where to classify into. Like you don't know whether you're classifying this mail into spam or not spam. You just say whenever you receive mail, just classify it based on what you see. So you cluster. Cluster simply means classifying without knowing beforehand the various classes or labels. Now, the various machine learning problems can be put into graph. Like this is classification, classifying. These mails are good mails, they are not spam. These ones are spam. This is regression from the way these values are linked to this line. You're able to predict the next value that will be there, which will be around here. Clustering, you have the same things, but you want to cluster them according to, you don't know them, but when you now cluster, you can be able to say that these are red balls, these are blue balls, these are, but beforehand you didn't know whether these ones are red balls, but because of the features that you have in them, you can cluster them. So that is clustering problems. So those are the three major types of machine learning problems. There are also the three major types of deep learning problems. So you see that some of the features that we see in machine learning, we also see them in deep learning. Now, what are the applications of machine learning? When you talk about machine learning, artificial intelligence, where are they used? Machine learning can be used in web search engine. Like Google uses machine learning to tell you if you're a football fan, whenever you get to YouTube, you'll be seeing things concerning football. If you're any news that you're interested in, whenever you go to Google to search more of it, you see that when you go to Google app on your phone, you see things concerning that. Photo tagging and photo application, just like I showed you, machine learning can be able to classify photos. Like it sees one, it tell you that, oh, this is a phone, because it has ability to read images. Spam detectors, like I have explained, ability to detect spam cells and spam mails and rest of them. Today, companies are using machine learning to improve business decision, increase productivity, detect disease, forecast weather, and do many more things. Data mining for growth information can be used for this. Application that cannot be programmed, you can use machine learning, just like driverless car, face recognition, handwritten recognition, and so on and so forth. Understanding human learning can also be an application of machine learning. Now we'll talk about the machine learning algorithms. What are the algorithms that you can utilize to solve machine learning problems? Number one is linear regression. We have logistic regression. We have decision tree. We have SVM, support vector machine. We have naive Bayes. We have KNN, also known as K-nearest neighbors. We have K-means, and we have random forest, etc. There are other ones. Now, what are the terminologies that you use in machine learning? You hear terms like model. You have to prepare your model or build your model. You hear terms like features. Features are those characteristics that you use to identify and classify data into labels. Labels are the target. Training is the ability, is the use of these features and labels to train the model, and you make prediction after you must have trained the model. The essence is to make prediction and tell us what we don't know before, and that is machine learning. Now, there are basic difference between machine learning and traditional programming. In traditional programming, we feed data to a program, run it and get the output, whereas in machine learning, we feed data and output together, run it on a machine during training, and the machine creates its own program called logic, which can be evaluated while testing. Now, how does machine learning or deep learning work? Number one thing is that you must gather your data. You get your data of plenty dog or cat images. Now you process this data, you find out the data that are missing, you know how to arrange them. Now you divide the inputs into training, validation, and test sets. That's what you do next. So after dividing the whole lot of data that you've collected, divide it into training, test, and validation. Now you build your model. After building your model, you test your model and make predictions. Now, what are the prerequisites if you want to learn machine learning? What are the things that you're supposed to know before you start your machine learning. Number one, linear algebra. You are supposed to know that in school when you're learning mathematics. People from engineering background and science background are going to be used to this. Linear algebra, statistics and probability, calculus, graph theory, programming skills. You can use Python. Python is the most used language for machine learning. You can also use R, MATLAB, C++, and Octave. Now we go to deep learning. What is deep learning? Deep learning is an aspect of artificial intelligence that is concerned with emulating the learning approach that human beings use to gain certain types of knowledge. So in deep learning, you're using the concept of neurons in the brain, the way they do their learning. You can see this is neuron. This is a diagram of neuron. And now when you feed inputs, the neuron takes the weights of these various inputs, adds them, and uses an activation function to fire and predict the output. So the way deep learning works on neuron, that's the way the normal neuron work in the brain, and that's why we call it artificial neural network. Now these are also the diagram that I showed before, showing the relationship between artificial intelligence, machine learning, and deep learning. You see that artificial intelligence, the method or major method used in solving artificial intelligence problem is machine learning, and now there is the development of deep learning that is even stronger, that we now use in solving artificial intelligence problem. Now, deep learning architectures. What are the deep learning architectures that we have that we are going to study if we want to start solving deep learning problems? We have the artificial neural network, also known as neural network. We have the deep neural network. We have the deep belief network. We have the recurrent neural network. We have the convolutional neural network. We are going to take this one by one. Now, what are the aspects of application of deep learning? Where and where can we see deep learning being used? You can see them in healthcare. If you want to determine whether somebody is going to have cancer, you can take measurements of data concerning the person's body. Then you can use it to predict whether somebody can have cancer, so that you can prevent it in future. That is healthcare. Automotive, you'll be hearing about driverless car, automatic driving car, where nobody will be driving, the car will be moving. So they use what we call artificial intelligence, neural network, to find out, to be able to avoid accidents and all those. Automotive, finance and economics, you use neural networks and deep learning to predict the stock prices. Government can use it to monitor a whole lot of cyber crimes, and video game, you can use it to automatically play video game against the machine. Military can use it in a whole lot of ways, audit, advertising, and arts. Now this is basically what a neural network is. A neural network are sets of algorithm modeled loosely after the human brain and are designed to recognize patterns. So they actually built on neurons. This is neurons. This is the actual diagram of a neuron having node and dendrites from where it receives input. So this will be the node in the neural network. It receives inputs about the features like x1, x2, together with their weights, sums them and fires with an activation function to give an output. This can even be seen more like this. This is a single layer neural network, because it's having one hidden layer. This is the input layer where you receive various inputs like the shapes of the material being classified. So it receives it here in this neuron, it fires and gives you the output. So this is basically what happens. This is a single, whenever the hidden layer is just one, call it a single layer perceptron. So this is actually what happens. It receives input with the weights, it sums it, and it fires to give output. This is what happens in one single neuron. So these are the neurons. When you have a single hidden layer with the input layer and the output layer, we call it single layer. But when you have plenty hidden layer, like this one, we have hidden layer 1, hidden layer 2, hidden layer 3 before the input and output layer, we call it deep neural network. So deep is when the hidden layers are more than one. Now we'll talk about convolutional neural network, when you have to look at the layers, plenty layers, starting like this is human face. But you know that deep inside human base, you have something like all these lines. You understand? These lines make up the nose, the eye. Then the nose, the eye make up the face. So you talk about convolutional in image detection. This is exactly the kind of thing that you see in order for you to study. So you have from the line to the next layer where it's coming together to the abstract high level layer where you can see with your eye, like the face. But the face, you know, is built from lines then the objects of the face like the eyes and the nose before the face. So this is successive model layers learn deeper intermediate representation in convoluted neural network. So this is about where we're going to be stopping today. In subsequent classes we are going to go dive deep into using those neural network architectures and algorithms to solve real problems. Please, if you like this, hit the subscribe button. If you have any questions and concerns, drop it on the comment section. Thank you and God bless you.